Hey everyone, welcome to the Being Patient podcast. I'm Deborah Kahn, founder of Being Patient. When my mom was diagnosed with Alzheimer's disease, I decided to use my skills as a journalist in a different way. Frustrated by the lack of information on science and the inability to get different expert opinions, I decided to quit my job at the Wall Street Journal to create a better platform for people impacted by dementia. We are a community where news and information is created by our team of journalists. We ask tough questions and we simplify the science so that anyone can understand. We don't only cover disease, but delve into the latest research on what it takes to keep our brains healthy. We invite the experts and ask your questions. Here's today's podcast. I hope you enjoy it. Welcome to Being Patient Brain Talks. I'm Deborah Kahn, founder of Being Patient. And as all of you know, we like to focus and cover the latest research, not only on Alzheimer's, but also on brain health. So today I thought we'd talk about metabolism, and specifically, how does metabolism relate to better brain health? I've been following Dr. Ben Bikman for a while now, who joins us from Brigham Young University. Welcome, Ben.
Oh, Deborah, my pleasure. Thanks so much.
So I love the work that you're doing, and I feel like a lot of people don't understand, and admittedly, I didn't before I embarked on this journey, how specifically different biological systems relate to our brain. I feel like it's really the brain is often left off out of the conversation just because there's so much we don't understand about it. But let's just start with what we do understand. Now, in very basic terms, the brain feeds itself. Its fuel comes from glucose within our body. Is that right to say?
Yeah. In fact, I would even preface that just by emphasizing the brain's remarkable metabolic rate, where it is in the top 3 of what is called this kind of trinity of high metabolic rate organs. And it's always, even when we're asleep, its metabolic demands are still remarkably high. So it has a very high energetic need. It has a high demand and it needs a lot of energy. And that is actually helping us identify problems that we'd never really seen before, specifically with neurological disorders, not just Alzheimer's disease as maybe the lowest hanging fruit, but there are numerous neurological disorders now that appear to have a common core of a metabolic deficiency. And you're accurate in pointing out glucose. Glucose is one of the 2 fuels that the brain primarily relies on. And unfortunately, that glucose use by the brain is regulated by some other processes. And I don't want to get ahead of myself here, but suffice it to say that yes, glucose is a brain fuel. Unfortunately, we live in a culture and a society, the way we eat and live, where we're demanding that the brain only use glucose. And as luck would have it, that's the energy source that the brain is increasingly having a hard time use for various metabolic reasons.
Okay, so just in basic terms, we break down carbohydrates, and carbohydrates are what lead to glucose production. Is that correct to say?
Yeah. So glucose is a fuel that can be used by every single cell of the body. So thankfully, it's something we get readily in the diet, but even more thankfully, we make all that we need. So yes, any carbohydrate that's coming in the mouth can turn into glucose in the blood. That's great. And that's what we eat plenty of, perhaps too much, and we can get into that later. But also, even in the absence of eating any, the liver is kind of the great giver when it comes to nutrients in the body. And if it senses that blood glucose levels are starting to drop, it will simply start making glucose and sharing it with the body. Indeed, it does it so well that the liver is capable of making up for any absence of carbohydrate in the diet. So that's why someone could go on a multi-day fast, not be eating any carbohydrate, and yet their glucose levels stay totally normal. That's because the liver is able to make literally all that we need.
So when is it that we have to, okay, before I ask that question, let me ask you another one. Now, I have been told as we age, we actually are less efficient in producing glucose. So our glucose supply diminishes as we get older. Is that true?
No,
That's not
No,
true.
that's
Okay.
not true. Yeah. So now our ability to use the glucose is compromised. And so while our ability to put glucose into the blood is as good as it ever was, our ability to move it out of the blood is what's affected. And that ultimately means, paradoxically, we have an increase in blood glucose and yet an increasing inability to utilize it, and so it becomes a bit of a vicious cycle. But that is at the heart of the brain. Not to necessarily bring it back to the brain too quickly, but it is that inability to move glucose from the blood into the cells where it would be used for energy that is really appears to be the foundational issue in many neurological problems, even Alzheimer's disease.
So how does that inefficiency, does that just mean in very layman's term that we're not getting enough fuel for our brains and therefore problems can begin to start?
Yes, that's exactly right. And that's in two reasons. My lab has identified one of them and others have identified the other. I'll start with the other one and I'll come back to the one my lab has found. Firstly, the hippocampus is the little pocket of the brain that's most relevant to memory and learning as we kind of form this conversation on Alzheimer's. But to varying degrees, the same thing is happening elsewhere. But suffice it to say, that much of the glucose that's coming into the brain to be burned for energy requires the humble hormone insulin. Everyone has heard of insulin, and insulin's most famous effect, not that I'm saying it's most important, because insulin does a lot of very important things, but its most famous effect is what it does to glucose, where insulin will essentially come and knock on a door, including the neurons in the brain, and it will open those doors and allow the glucose to come from the blood into the cell, providing the cell with fuel. Well, as the brain starts to become insulin resistant, now you have insulin politely knocking on the door. Maybe even it's pounding on the door of the cell, but the cell won't open up and allow the glucose in. So you have this kind of bizarre, kind of demented version of the rhyme of the Ancient Mariner, where it's not water everywhere, but glucose everywhere, but not a drop to drink. That's sort of the cry of the brain, where literally blood glucose levels may be twice as high as they should be, and yet the brain can't get it because insulin isn't working well enough. That's where the inefficiency comes in, where the brain has this high of an energetic need, and ideally, I shouldn't say that. Normally, glucose would be providing it because the person's eating so much glucose. But as the brain starts to become increasingly insulin resistant, now you start to have this energetic gap where the brain needs this much energy. And because glucose is the only fuel available to it at the moment, although there's another fuel, but there's this gap. And that
Right.
gap is what starts to create not only the memory learning and deficits like you see in Alzheimer's disease, but even the reduced dopamine production that you see with Parkinson's disease, or the epilepsy that you see, the seizures that you see with epilepsy, and even migraine headaches. All of these, despite being on their surface distinct disorders, they all share this known and confirmed what's called brain glucose hypometabolism. In other words, a brain that is burning less glucose than normal.
Okay. And I knew this question was going to come quickly, and I knew that this is what you keep referring to, what we'll talk about later, which is ketones, because ketones being an alternative source of fuel for our brains, capable of crossing the brain-blood barrier, are they as efficient a fuel as glucose?
That's a wonderful question. In fact, yes, they are. In fact, the best available evidence suggests they're more efficient. So you literally create more chemical energy when the brain is burning a ketone than it does burning glucose. So yes, it is at least as efficient, if not more efficient. And we always say, and I even say this, you just did, we say that ketones are an alternate fuel, but the reality might be that it's the primary fuel. And case in point, if we start to increase the ketones in the blood of a person, even though the ketones are much lower than the glucose is, maybe it's only a quarter as much in the blood, even still, the brain immediately starts relying on ketones. And as ketones go higher and higher and higher, the brain continues to rely on the ketones more and more as its fuel. And that's actually somewhat reflective of what I didn't get around to in the moment, but my lab's work, where we actually were able to get tissue from human cadaver, from tissue donors, and study the difference in gene expression between those genes that are involved in glucose burning versus ketone burning in people who had died with Alzheimer's disease and with no Alzheimer's disease. And it was the glucose burning genes that were compromised, not the ketone burning genes. And that is so powerful, because if a person has an energetic gap, well, then let the brain eat ketones, and ketones can more than fill that energetic gap and indeed improve cognitive performance.
So can we get, okay, I know, obviously most people know now what a ketogenic diet is. Like if we fast, for example, then our body starts to burn ketones, and that's when we are, utilizing ketones. But my question is, I know you can supplement ketones as well. Do we know, because, frankly, a ketogenic diet may not be good for everybody, right? It's not a one size fits all, and metabolisms are complex. And for whatever other health reasons, ketogenic diet may not be the best thing out there. Can we supplement ketones? And if so, does it have the same impact?
Yeah, what a wonderful question. Yes, you can. We can supplement ketones, and I can state that authoritatively because there are, in fact, human studies that have been published that prove this, where you take people with Alzheimer's disease, you give them cognitive tests, you give them a ketone supplement to dramatically increase their ketone levels in their blood. You have them conduct those or perform those same cognitive tests, and they perform better. So the evidence is quite strong. Now, a ketogenic diet, how you described it is accurate. I would simply add another layer to it. You described a ketogenic diet as a ketone burning diet, but you have to take the first step, which is that it's ketone making. And of course, as ketones go up in the blood, virtually every cell in the body will start to use the ketones for energy. So that part is very much true, but it all boils down to insulin. And that kind of allows me to address the other part of your question, where are exogenous or supplemental ketones the same as making your own ketones? The ketone is the same. That molecule is the same, but so much of the benefit of a ketogenic diet isn't necessarily the ketones, although in this context, they're very relevant because it's providing the brain with the fuel. But the primary benefit is lowering the insulin and improving insulin sensitivity. Because remember, at the root of the neurological fall is that the brain starts to become insulin resistant. And so the power of a ketogenic diet, not that I ever intend to advocate it in all sincerity, but I would say Alzheimer's disease is probably one of the situations that would benefit the most from a ketogenic diet, from an explicitly ketogenic diet, one that is keeping the insulin so low due to very low carbohydrate consumption and fasting, that you're not only improving insulin sensitivity in the body, including in the brain, allowing it to use glucose better, but you're also making ketones, which simply, just to demystify ketones in a few words, ketones are simply products of fat burning. When the body is burning fat at a very high rate, which it does when insulin is low, it's essentially burning more fat than it needs to use for energy, and it starts turning some of that burning fat into ketones. And then ketones are a viable fuel in their own right, especially for the brain. So 1-to-1, a ketogenic diet, not that I mean to advocate it, but I will certainly defend it, will have a greater metabolic benefit, even to the brain, than just supplemental or exogenous ketones, as beneficial as they are. And to your point, for people who are unwilling or unable for whatever reason to adopt a ketogenic diet, which admittedly could be difficult in someone with Alzheimer's disease, right? They may be very obstinate and difficult and just refuse to do this. Well, then knowing that you can rely on an exogenous ketone, despite the considerable expense associated with them, is nevertheless a bit of an encouraging note.
Okay, and we have a question from someone in our audience who has been diagnosed with dementia. So do we have any evidence that, I mean, we've been talking about it in terms of brain health and prevention, but do we have any evidence that it could slow down the clock on Alzheimer's? I mean, I'm assuming we know there's no reversing what's already been started, but is there any scientific evidence out there that says that we could actually slow the clock in terms of the progression of Alzheimer's or other types of dementia for that matter?
Yeah, that's a wonderful question. There's no evidence in clinical studies that have used very tightly controlled dietary interventions. However, there are case report studies that have been published showing that, yes, in early stage cognitive decline, you can in fact reverse it. There was a series of studies published by a scientist named Dale Bredesen, and he has found this. Again, they're not clinically controlled studies, they're case reports, which is just to say you notice what's happening in the patients. But he's very explicit in noting the cognitive improvements, emphasis on improvements, not just slowing the decay or even stopping it, but actually reversing it by encouraging the increase of ketones through fasting and low carbohydrate diets, as well as the consumption, not of, he didn't publish a paper on exogenous ketones as a supplement, but rather including medium chain triglycerides in the diet, like coconut oil explicitly. Coconut oil is enriched with a type of fat that is burned at a much, much higher rate than normal fats, like from meat or dairy or vegetable oils. These are burned at much higher rates and are thus more capable of increasing ketones in the blood fairly rapidly.
Yeah, I mean, I think the public is really confused because, you know, there's these internet videos that go around, show somebody getting a teaspoon of coconut and suddenly being cured, you know, and certainly don't want to give any illusion that it's that easy, right? But what you are pointing out is how our complex systems really relate and how they benefit. And another question came in asking there's different types of ketones out there that you can supplement. Are there ones specific to brain that we should know about?
These are wonderful questions. So there are two primary families of ketone supplements that are available. One, and the older one and the cheaper one, older meaning it's been on the market for much, much longer, is what's called ketone salts. And then the newer one, the new kid on the block, much more expensive, but significantly more effective, is a line of a brand or type rather of ketone called a ketone ester. So the former, the ketone salts, are very affordable. They don't increase your ketones as much, and they come with the consequence or consideration that they have very high levels of, well, salt, if you will, these molecules like sodium and potassium and magnesium. And that can result in maybe an increase in blood pressure. It can result in just kind of awkward mineral deposits on the teeth because you're getting so much calcium and magnesium and potassium that the body just starts excreting it. Yes, in the urine, hopefully not increasing kidney stones, but even in the saliva, making there a noticeable mineral deposit on the teeth. And then the ketone esters have none of those consequences. They're just much more expensive.
So what does it mean? I mean, you know, sometimes Alzheimer's is referred to diabetes on the brain, right? Mm-hmm. So why do we say that? What exactly does that mean?
Yeah, so I actually don't love that term, but I like that you're bringing it up so that I can kind of knock it down a little bit. So when people will call it type 3 diabetes or diabetes of the brain, I think that kind of confuses the issue to your as you're asking this question. Even it's unclear. The more accurate term is insulin resistance of the brain. And that's how they make the connection, because insulin resistance is the foundation of type 2 diabetes. People just think they're being clever and saying, well, it's type 3 diabetes. It's an insulin resistance of the brain. Well, that's just part of type 2 diabetes itself. And so I like that we can talk about this so that I can kind of shoot it down a little bit. The more accurate term would be you have type 2 diabetes and now it's affecting your brain, or even more accurate, you have insulin resistance of your brain. And that is not allowing the brain to get as much glucose as it would normally be taking in.
So insulin, I mean, to kind of back up a little bit, insulin resistance is when we have too much insulin. Is that right? And our body doesn't know what to do with it. Is that being insulin resistant?
Yeah, that's pretty accurate. So we put
on fat, or is that right?
But we don't have to go to that though. We don't have to invoke fat, although I certainly am capable of and always thrilled to talk about it. But just with regards to insulin resistance in its purest definition, it is when the body has too much insulin and it's not working very well. And those really play into each other in a vicious cycle. So sometimes it's hard to tease out, well, which came first. In the end, it becomes a little irrelevant. You have high insulin and it's not working well. And so those are both, they each represent different points of attack where we have interventions where we try to help the insulin work better, like exercise. And we have interventions where we're trying to lower the insulin, like fasting and low carbohydrate diets. So we can address both of this on either side.
And someone had asked, what about metformin? Isn't that the drug you take for diabetes, right? That some people are taking for longer health. I've heard like they're kind of going off prescription and using it to metformin. So what are your thoughts? I mean, obviously we're not advocating people run out and take prescription drugs. They're not prescribed, but how does metformin fit into this picture? Because I've heard of like people have even told me they take it for brain health.
Yeah.
Is that something that is at all valid or what?
Yeah. So it is valid, but there are some strong considerations that someone ought to be aware of. So metformin is a drug that, as strictly as a scientist, not as a clinician, certainly, of course, not giving any dietary clinical advice, that I actually give maybe the highest grade to. When it comes to drugs that will improve insulin sensitivity, I put metformin at the top, in part because it does work. It does improve insulin sensitivity. And at the same time, it has relatively modest side effects. Every drug has side effects. Metformin's, in my view, are more than outweighed by the benefits, and the side effects are generally quite mild, which is why I say that. Now, there is, because metformin does improve insulin sensitivity, I think it would be warranted in someone who doesn't have obvious signs of type 2 diabetes, but does have obvious signs of cognitive decline or early stage Alzheimer's. I think that would be in anyone's interest in asking. It's also a very cheap drug, which I'm always an advocate of. It's off patent. But using metformin as an effort, as an anti-aging drug, I don't think is warranted, in part because of how metformin acts on muscle, where we know that in people who take metformin, they literally can't exercise as well. Their aerobic capacity is significantly diminished because the metformin can alter, or even, dare I say, hurt metabolic function in skeletal muscle. So there's a consideration. And of course, there's no evidence in humans to show that it promotes longevity whatsoever. That's just all speculation. And I'm not saying it's baseless, but it is speculation.
Yeah, this is a great question too. Are all patients with Alzheimer's technically diabetics?
That's a wonderful question. No, but certainly not diagnosed. I would, and there are a few different types of Alzheimer's disease, but the vast majority of them would be the kind of conventional energy one that we're talking about that was thought to just be a matter of plaques, but isn't. I would say in those instances, the type 2 the insulin resistance is likely undiagnosed, but I bet it's there. It's just never been detected.
So we're getting so many great questions. I have to kind of take them one at a time. So sorry if we're jumping around. Okay, I like this question too, because I wonder this myself, right? And so what someone has done is kind of like listed certain foods and wondering what is the glycemic impact of these foods, right? So for example, wine, that's one we all want to know. Should we be having our 1 or 2 glasses of wine with our meal at nighttime?
I can't speak to wine necessarily, but I think the insulin effect of wine is going to be quite modest.
And what about lower carb, higher fat cream instead of milk if at a normal BMI?
Yep. Yeah, that would have little to no insulin response.
And what about an insulin response to like all the fake sweeteners, from Diet Coke to stevia? Yeah. What do we need to know about those?
Yeah, that's a great question. There are so many non-caloric sweeteners that I can't lump them all into one answer, but I will say this: the overwhelming majority of them, certainly the most common, like you get in diet sodas, have no effect on insulin. So aspartame has no effect. Stevia has no effect. Monk fruit extract has no effect. However, some of the what's called sugar alcohols, like maltitol or mannitol, do have an effect, albeit less than sugar does, but still more than nothing.
Okay. And so is it fair to say, if for all of us, maybe at an earlier stage of Alzheimer's, or who don't have Alzheimer's, but a loved one with Alzheimer's, like myself, who has a mother, would you advocate for a low carb, like ketogenic diet? Would you advocate as a scientist? What's your recommendation to us?
Yeah. So I, to a degree, share your concern. I don't have a parent with it. My mom died years ago, so she was spared that. But my dad's mom fought Alzheimer's for years. It was very sobering for me to see, and I worry about that myself. And while I don't ever want to just say make a blanket encouragement for a ketogenic diet, what I would say is I think it is in everyone's best interest that at least for some chunks of hours in a week that they make sure they have ketones in their blood. In other words, that they're in a state of ketosis. And the easiest way to do that is fasting. Even if someone just can do one 24-hour fast a week, a food fast, they could drink water or other things that won't spike insulin, like, coffee or tea, unsweetened from sugar at least. Then you can ensure that your insulin is coming down and that you can have some ketones. That'll help your body be a little more insulin sensitive, keeping insulin sensitivity working well as insulin goes low, and you're fueling the brain with ketones. So I don't intend to say it's got to be a ketogenic diet or bust, but I think it's very, very worthwhile to ensure that at least some part of the week is spent in ketosis. And again, the easiest way is fasting, not only a 24-hour fast, but perhaps choosing 3 or so days a week where you fast through breakfast. You've eaten a good, sensible dinner at, say, 6 or 7, and you've stopped eating then. And then by the time you eat lunch the next day, you'll be in a mild state of ketosis, almost certainly. And it won't be too uncomfortable.
Is that because it's really better for us to flip systems, like where we're fuel burning, how we're fuel burning? Does that equate to brain health, or is it just that it's not really realistic that everyone goes into ketosis 24/7, so therefore it's better to go back and forth?
Yeah, it's the latter. So there's no evidence to suggest that having the brain switch between ketones and glucose is somehow more beneficial. There's no evidence on that. Maybe, but I don't think that's the case. It's just more that what you said, where it's just unrealistic for the majority of us to say, okay, I'm in ketosis and I'm never going out of it. It's rather, let's just be smart with our carbohydrates. We're avoiding the most processed of them for the most part of the day. And we're making sure we have these periods of time where we are keeping insulin low, either through low carb or even faster through fasting.
Okay, so I want to talk a little bit about your research, because you have some brain research going on right now, specifically on the hippocampus. So tell us exactly what you're researching and what you're finding out.
Yeah, I mentioned the paper from last year where we had the data from human tissue. That is precious and hard to get. And so after doing that, we've moved into rodent models, which provide very interesting comparisons for humans. And certainly metabolically, it's a valid comparison. We're finding that ketones are increasing energy production, or rather maintaining high energy production in older animals, and it's increasing their curiosity and their exploratory behaviors. So these are brains that aren't satisfied just sitting there. They want to be learning and exploring. And we hope to publish this by the end of the year, maybe even by the middle of the year this year. So these are brand new data. My PhD student will be publishing these, or presenting these at a conference this upcoming April. But yeah, suffice it to say, so the ketones are providing a literal increase in energy production in the hippocampus. And that is translating into observable changes in behavior, like more rapid movement. The animals are moving more, they're exploring more, and appearing to remember more.
Is it similar to what they have found in animal studies with exercise, where actually exercise, the aerobic exercise, the endorphins actually lead to more gray matter in the brain and better within the hippocampus? Would you say it's similar to that?
Yeah, so we've not quantified gray versus white matter. That's a good question. That's not in the scope of what we're doing. We're just looking at the kind of the biochemistry of it, or the bioenergetics of it, to be a little more precise. But yes, I suspect strongly that it would fall along those same lines.
Okay, and then we have another question about the beta amyloid plaque. Obviously, that's the hallmark for Alzheimer's, one of the first presumed stages of the pathology.
It's garbage. It's garbage, though, Deborah.
Why?
It's garbage. Really, that's the theory that has fallen apart.
Yeah.
It just continues to fall apart, where we have post-mortem data on humans finding that humans will die with Alzheimer's disease or without Alzheimer's disease, and there's no predictive power of who had plaques or who didn't. You'd think if plaques matter, then everyone who died with confirmed Alzheimer's disease would have plaques in their brain, and those who didn't have any evidence of Alzheimer's would have no plaques. And that's just not true. Plaques are high or low, whether they had Alzheimer's or not. In fact, a very interesting thing happened last year, where the FDA was going through the approval process for an Alzheimer's drug. I wouldn't be surprised if some people saw these headlines. It made waves. Basically, this drug was approved by the FDA, despite the special panel overwhelmingly voting against its use.
Yeah, our audience will know about this. Aduhelm. It was aducanumab and now Aduhelm. Yeah.
Yeah, and what they found, the reason the panel voted against it is because it showed no powerful efficacy, certainly none worth the cost. And you think if this were working, it'd be worth any cost. And so the more that just falls in the same line of a number of drugs that are these anti-plaque drugs, and they just don't work. That's really, I think, been the primary reason that the energetic view of Alzheimer's disease has become so popular, because it has so much more substantial data to support it. However, not a lot of drugs necessarily, which is why maybe it will never be totally mainstream. Something's only mainstream when there's an expensive drug to go along with it.
So in other words, I mean, the whole hypothesis is with these MAB drugs, the monoclonal antibody drugs, is that they can take away plaque, right? But the question still remains, is less plaque in the brain, does that equate to an improvement in cognition? And that's right. Still something that has yet to be proved yet. You know,
yeah, that's right.
We don't know the answer to that.
It has yet to show any demonstrable efficacy.
Okay, so we have another question back on the ketones, and someone is asking, you know, if you're using exogenous ketones, how do you determine how much to use? So how do we know if we want to supplement, it's enough to benefit our brains?
Yeah, I can't answer that definitively, just because there's no data that has kind of quantified and measured this effect. If a person, if they're taking a ketone ester, then usually one shot, and I think that's going to be around, maybe it's around 50 milliliters. That's generally going to increase their ketones, probably 50 to 100 milliliters. That'll typically
increase. Isn't it usually a powder that you mix with something
exogenous? Well, no, the ketone ester, I only am aware of it coming in a liquid form. The ketone salts will always come in a powder. And you have to take a lot of ketone salts, almost more than is feasibly possible, to get to the level that you can just with a modest amount of ketone ester. So like a little shot glass size, 50 mils of a ketone ester will get the person to a very strong state of ketosis, about 2 or 3 millimolar, which would normally take about 36 hours or so of fasting to get to that point. A ketone salt amount will maybe get you to, honest to goodness, a tenth of that, maybe about 0.3 millimolar, which you could argue is not enough, although that's not been quantified. But the difference between ketone ester and a ketone salt is very, very clear. Now, I don't mean to sound like I'm advocating ketone salts, but just because I'm a scientist, I'm going to be very frank about it. There's no question that ketone ester is significantly more effective. But again, for most people, it's unfortunately cost prohibitive. It's just very expensive to make.
So we've interviewed a scientist before who says that the hypotheses behind ketones should really be tested on brain injury. So concussion, for example.
Oh, yeah.
If we can prove that ketones can actually speed up the healing process, then it's not as far-fetched to think that ketones could play a big role in brain health. What do you think of that?
That's a wonderful perspective. Frankly, I've never heard that before, but I appreciate the sentiment a great deal. What's interesting about traumatic brain injury, in fact, I think there is evidence, at least in rodents, to show that ketones do enhance recovery from traumatic brain injury. In fact, I'm quite confident even that to a degree that is used even clinically nowadays, where someone experiences traumatic brain injury, they're given a solution of lactate and ketones, both of which provide a fuel for the brain and enhance the recovery. What's interesting in a TBI, a traumatic brain injury, is that part of what has happened is that there's a damage to an enzyme that mediates glucose burning. This enzyme called pyruvate dehydrogenase gets compromised oddly, and through mechanisms I don't know, but it has been measured and it is lower with TBI. And so there might be a direct attack on the ability of the brain to use glucose. And then essentially any other fuel would then become therapeutic, whether it is ketones or, I hate to bring in a new character, but even lactate is a fuel for the brain.
Tell us, you can't tease us that way. What's lactate and how do we get it?
Well, that's the kind of dreaded molecule that's been very erroneously vilified, where people will say, oh, I have muscle soreness. That's all this lactic acid. Well, that's wrong in every possible way. Humans don't ever have lactic acid. It's just a molecule called lactate, which isn't contributing to acidity whatsoever. And second, it has nothing to do with muscle soreness. Lactate doesn't make a muscle feel sore, but lactate is something that is made from a working muscle. And then the liver can take in that lactate and turn it back into glucose through this incredible process of, recycling biochemistry, and to give it back to the muscle to use the glucose. But at the same time, tissues like the brain actually can just pull in the lactate and literally burn it as a fuel, like it would ketones or glucose, albeit in much more modest amounts. So we don't call lactate a primary brain fuel. That's glucose and ketones, but it's certainly, if you will, a tertiary brain fuel.
So what would you say if I were to say exercise or ketones? What's more important for brain health?
Oh, gosh. That's a good question. It's difficult for me to commit. The easy answer would be, well, exercise, because boy, that does all kinds of good things. But I don't know. I've never seen a study that has looked at cognitive decline and reversal or therapy with exercise, whereas I know many papers that have looked at the role of ketones in improving cognition. So if I had to stick to one, I would just have to go with what I know, which is ketones, because it works. But I'm a huge advocate of exercise. Exercise will enhance ketogenesis in its own right, because when you exercise, it lowers insulin and ketone production will go up. We published a paper last year finding that if you exercise at the beginning of a fast, you get into ketosis much more quickly. And that might be something that people could leverage and take advantage of. So if I have to pick, I would say ketones, just because I know those papers have been published, but the difference between the two might not be as different as most people think.
The other thing is that's interesting to me is when we think of insulin resistance, or, we tend to think of people who are overweight and clearly visibly have a problem, but that's not necessarily the case, right? I mean, you can be thin and you could be insulin resistant. So talk to us a little bit about how people understand whether or not they're insulin resistant, and what we can do to really help us understand that.
Yeah, that's exactly right. While the vast majority of people who have insulin resistance will noticeably have more fat, it's not always the case. And we know this even from young people in their 20s, that they can have a normal body weight and yet have higher insulin resistance, especially at the level of their fat cells, which is where I believe insulin resistance begins. Even if you can't kind of normally detect insulin resistance through conventional means, if you do kind of extra tests that nobody could do at home, unfortunately, but blood tests in a lab, you can detect insulin resistance at the fat cells. So yes, it can happen in people who are not noticeably metabolically unhealthy. However, there are some generally reliable signs In fact, I should say always reliable. It's just whether or not they've manifested. But every time you see them, it's essentially proof positive of insulin resistance. And those are skin problems that you can see. And there are two of them. One of them is acanthosis nigricans, which is where the person will have large, rough sections of like crinkled, almost tissue paper skin. And it'll happen around skin folds, very commonly around the neck. Most people have some kind of modest degree of a skin fold, even if you're lean. It can happen around the neck and it can happen around the armpits. So again, it's kind of tissue paper, crinkled type skin. In those same areas, a person can start to have skin tags. And these are little stalks of skin, not like a big round mole, but almost like a little kind of projection, like a little mushroom of skin, albeit quite small. And I bet everyone already knows what I'm talking about. These are like little mushrooms of skin that'll pop up in these same areas. And that, again, those are skin tags. Once again, almost proof positive. It's almost a sure thing that if someone has those, they have insulin resistance.
Why? Do we know why that happens?
Yeah, we do. In both instances, it's a result of the elevated insulin. Remember, insulin resistance is insulin isn't working the same way that it used to, but also insulin levels are much higher. In each instance, insulin is overstimulating some of the skin cells. In one hand, it's stimulating the melanocytes to produce more melanin to result in a darker pigment in those areas. And then second, it's stimulating the growth of the keratinocytes, kind of one of the many types of cells in the skin, resulting in that kind of column-like growth.
Okay, and I'm asking this purely from a very selfish perspective because I'm tired of screaming at my 15-year-old to stop eating sugar. Yeah. And that, does she really understand what it means and what's happening to her metabolism and insulin resistance? What should we just not eat refined sugar? I mean, obviously carbohydrates, can turn into refined carbohydrates are kind of in that same category. But what is your advice to us? Like, how should we be eating? What should we be avoiding? I mean, we know we should fast intermittently, but what else can we do?
Yeah. So very, very briefly, and then I'll come back to this specific question. I believe that there's 3 rules. Control carbohydrates, prioritize protein, good quality protein, which is always going to be animal. I know that's uncomfortable to say nowadays, but it is better than plant proteins. And then last, don't be afraid of fat. Now back to the first one, because sugar falls into the control carbohydrates category. I have 3 kids, 14, 11, and 8. So I feel the pain here. So I try to not present any food as illegal or off limits. I don't want my kids to have that kind of view so that when they someday leave the home, they say, oh, to hell with dad, I'm going crazy now.
Yeah.
I don't want them to think that. And so I have tried to have just very casual conversations where I say, okay, you want a little pack of gummies? Have you had any protein lately? And that's kind of how I say, that's how I'll frame it. It's like, yeah, that's fine. You want to have an indulgence, but we also don't keep junk food around the house. It's very, very uncommon. But we will have some things, and I don't mind having those as treats for the kids. I really don't. Right. I'm glad I could have candy when I was a kid, and I just am glad I didn't ever have too much of it. And so I want to just generally create the same situation for my kids. But I will say, have you had any protein lately? You want to have that? Can you have a beef stick? What about a hard-boiled egg? Or, and all my kids like different things. Each of them, I swear, like something different just so that they can say they don't like what any of the others like.
Right.
Where my one daughter will like cheese. She'll have a cheese stick. My other daughter will like a beef stick. My other son likes cottage cheese. And so whatever it may be, I will just say, can you get some protein? And these proteins always come with fat. And I want my kids and my wife and I to always be eating real natural fats that always come with proteins. Don't be afraid of fat, but let the fat come with the protein the way nature intended it, if you will. So that's my view on indulgences as a family, certainly with kids. I want them to be able to indulge from time to time, but I don't have a lot of opportunities in the house. We don't keep candy in the house, relatively few opportunities for that, but we have it. It's just always preceded by, hey, can you eat some protein first? Just so they're appreciating what is real food and what is not.
Okay, we have so many good questions, and I know we don't have a ton of time, but I want to get this next question is very to your point about, what we should and shouldn't eat, as we talk about, more protein, lower carbohydrate diets, in order to promote ketosis. Someone has asked, what about the heart vascular impacts of more fat? Because we know, like when we talk about the brain, they always say what's good for the heart is good for the brain, right? So what about the fat, excess fat?
Yeah. So I actually would agree with that maxim. I would just say what people think is bad for the heart isn't. So there was a paper just published, actually, that was it was literally just published like a week ago in the Journal of Frontiers in Nutrition. So a very, very well-respected journal. And it was a prospective study that, to the best of our ability, scrutinized dietary habits in the United States from 1800. In fact, I hate to turn away from you for a second. It was literally just published, and I saved a copy of it, and I'll just read the title of it because it will address this so well. And people will know that I'm not just kind of making something up. So again, the title of it is United States Dietary Trends Since 1800. And the lead author has the last name Lee, L-E-E. So again, that was United States Dietary Trends Since 1800. If someone goes to scholar.google.com and types that in, it'll probably be the first hit. What they found is that the consumption of saturated fats is actually inversely associated with the onset of chronic diseases. And to say that another way, as we've been experiencing diabetes and heart disease and Alzheimer's disease, et cetera, we've, over the same time span, have been eating less and less and less saturated fat. Well, that's pretty difficult to reconcile with the prevailing theory, which is, I would say, the lazy one, that saturated fat is causing all of these diseases. It is simply verifiably false. There are even clinical studies that have looked at the explicit intervention of adding more saturated fats into diets versus more seed oil fats. And the saturated fats appear to be not only not harmful, but maybe even beneficial. So it's a very, very good study. It's prospective, which is analyzing dietary trends for the last 200 years. But the evidence is quite damning if you're an advocate of the idea that saturated fats are the devil.
And this is a good question too. Do probiotics promote ketones, and does the microbiome excrete ketones?
What an interesting question.
Do we know that?
Yeah, so I don't believe there's any evidence to suggest the microbiome will enhance ketogenesis. No, the microbiome will not secrete ketones. However, they do secrete short chain fatty acids, like butyrate in particular, or propanoic acid. So these are what's called short chain fats. They're very, very short, kind of like a ketone, although a ketone's not technically a fat, not technically a fatty acid. But it will make these short chain fats that can get into the blood and kind of act like ketones do, frankly. So that there's a little bit of there, while they're, again, not making ketones, but making short chain fats, which are almost analogous to a ketone.
Okay. And Dr. Ben Bikman, thank you so much. Honestly, I could probably go on for another hour if I could, because the topic is so interesting. And one of the things that we really, really want to highlight on Being Patient is understanding how biological systems relate only leads to better brain health. And no one is really explaining it to us. And that's what's frustrating. We talk so much around medication rather than what can we do through food, through diet, through exercise. What do we need to know in order to improve our brain health? So thank you so much for sharing your insights. How do we keep up with your research?
Yeah, thanks, Deborah. Thanks so much for inviting me. I'm moderately active on social media, and particularly Instagram. I try to put out 1 or 2 videos a week, and they're always just about a minute or two, purely about metabolic health. It's never shirtless pictures of freckled Ben Bikman or pictures of what I'm eating or doing something with my family. It's always just a little snippet of metabolic function. And I also have a blog, and people can find that at gethealth.com.
Okay. And for any of you who had missed part of this interview, don't forget to go to beingpatient.com. We always repost these interviews in case you want to know more. And also don't forget to sign up for our newsletters on our website. You can see a yellow button saying subscribe, because we will let you know about more of these upcoming interviews, and hopefully they're really helpful to you. So thanks everyone for watching, and we'll see you next time. Well, I hope you enjoyed today's podcast. For more information on upcoming interviews, don't forget to sign up for our newsletter at beingpatient.com. That's beingpatient.com. And send us any feedback you may have, whether it's someone you want us to interview or any comment about our podcast series. You can do so by emailing info@beingpatient.com. Thanks for listening, everyone. I'm Deborah Kahn.